This lesson is over complements. Let's review what complementary angles are. In your notebook, go ahead and write down the definition that I've got here. What complementary angles are two angles whose sum is 90 degrees. So we work a lot with supplementary angles, straight lines, and those add up to 180 degrees. In this case, complementary angles are two angles who add up to 90 degrees. So these three questions here, you can choose to write these in your notebook, or you don't have to because it's pretty simple what I'm asking. It says, what is the complement of 20 degrees? So basically, to figure that out, we would do 90 minus 20, and we would get 70. So the complement of 20 degrees is 70 degrees. The second one, what is the complement of 41? We would do 90 minus 41, which would give us 49 degrees. So the complement of 41 degrees is 49 degrees. And what is the complement of 84? That'd be 90 minus the 84, and we would get 6 degrees. So 84 degrees and 6 degrees are complements. Again, two angles whose sum is 90 degrees. Let's move on and apply this to trig a little bit. So we're going to look at some relationships here that you may have noticed already with right triangle trig, but we'll kind of cement them down today. I'd like you to sketch this triangle in your notebook for the example. And off to the side, I want you to find sine A, sine B, cosine A, and cosine B. You're going to write these as fractions, and you're also going to write them as a decimal to the nearest 10,000th place. So sine A, just like our work session we did yesterday, if A is our theta, sine is opposite over hypotenuse. So we've got 20 over 52. And to get that decimal to the nearest 10,000th place, you can just, in your calculator, do 20 divided by 52, and you would get 0.3846, tenths, hundredths, thousandths, 10,000ths. If theta was at our angle B, we would have sine B, and that would be 48 over 52. And when we do 48 divided by 52, we get 0.9231, because the 100,000th place is 7, so we round up. Let's do cosine of A now. So cosine of A, if A is our, if A is where our theta is, adjacent is 48 over 52. Wait a minute. That is the same fraction we just got from before. Interesting. So these two numbers here are the same. This one and this one. Sine of B and cosine of A. That's really interesting. Cosine of B, let's figure out what that is. Cosine B is, if theta is where B is, it's 20 over 52, which is exactly the same as the sine of A, what we found earlier. These two are exactly the same. So we have to wonder if this relationship that we just found, that the cosine of one angle is equal to the sine of the other angle, is true for every single right triangle. So we'll do kind of a general case to prove that it actually is. So when we look at this, let's say we had any triangle. This is just a Pythagorean triple example, a 3, 4, 5 triangle. We'll make sure we put the 90-degree angle in there. We know that A and B put together would be 90 degrees because triangles are 180 degrees. If you already have 90 of those degrees covered, you know you have to have 90 between the A and the B. If we looked at sine alpha, that A just stands for alpha, sine alpha would be 3 over 5, and sine beta would be 4 over 5. When we find cosine of alpha, that would be 4 over 5. And when we find cosine of beta, that would be 3 over 5. So when we look at that, we notice that, again, for any angle alpha, its cosine beta is going to be equal. For the cosine of any alpha angle, the sine of beta is going to be equal to it. So the relationship that we can sum up here is that sine of alpha is equal to cosine of beta, and cosine of alpha is equal to sine of beta. That relationship holds true for all triangles. That would probably be the first thing, or first thing I would draw off of this page. And again, if you need something in words, if the visual is not helping you, the sine of an angle and the cosine of its complement are equal. So the sine of alpha, its complement would be beta, because we know they both add up to 90 degrees. But the sine of this angle and the cosine of this angle are equal to one another. We just proved it in this general case with alpha and beta, and we proved it in this case where we had some different side lengths and actually looked at some numbers, actually found what they would be. So in trigonometry, the trigonometric function of the complement of an angle is called a cofunction. So what that means is that sine and cosine are cofunctions of one another. And that leads into algebra 2 a little bit when you talk about cofunctions in that relationship. But again, basically what it's saying is that the trig function of the complement of an angle is called the cofunction. What that means is whatever trig function you're finding for an angle, if you find a trig function for its complement, that would be considered a cofunction. So let's figure out a couple examples. I did these ones for you. You can copy both of these down into your notebook. Since we know, again, that sine of alpha is equal to cosine of beta, that relationship is always true, the questions that you're going to encounter are ones like this. We want you to write sine 42 in terms of cosine, so representing a function in terms of its cofunction. Those are directions, what we're just talking about. So sine 42, think about this. If we had a triangle and we were looking for sine of 42 and we wanted to represent that in terms of cosine, in order to figure out what this angle would be here, we would do 90 degrees minus the 42 degrees. That would tell us what this angle is right here. So sine of 42 is equal to cosine of 48. We know that this would be equal. Write cosine 36 in terms of sine. So if you had cosine 36 and you wanted to rearrange this, representing it in terms of its cofunction, the cofunction for cosine is sine. So we would do sine 90 minus 36, because again, we know it's going to be 90 degrees between the two angles that are left, and 90 minus 36 is sine 54. And again, from our work we did earlier, we know that cosine 36 and sine 54 are going to give us the exact same number. Those two trig functions are equal in this case. So take a moment and try these two on your own. Write each trigonometric function in terms of its cofunction. Pause the video and see if you can do it. And when you're ready to check it, just continue watching. So we want to write sine 28 in terms of cosine. So we know that sine 28 degrees, I put 280, sine 28 degrees in terms of cosine. So again, thinking about our right triangle, we would know that cosine of 90 minus 28 would be an equal trigonometric function. And here we'd have cosine of 62 degrees. That would be writing sine 28 in terms of cosine, giving us cosine 62. Those two trig functions are equal to one another. Cosine 52, or 51 degrees, we want to write that in terms of sine. So the cofunction of cosine is sine. So we're going to do 90 minus 51. And that would give us sine of 39 degrees. Good, so again, cofunctions there. The last item we're going to look at is finding unknown angles. So we're going to use this relationship, this complement cofunction relationship, to help us figure out what angles would make certain equations true. So our first one we're given, it says find two angles that satisfy this equation right here. So it says sine of 2x minus 4 degrees is equal to cosine of 3x plus 9 degrees. Now we know, because they're cofunctions, that these two are going to be equal. The sine of an angle and the cosine of its complement are equal. So we also know that the sine and the cosine, whatever angle degree measures those are, we also know that they're going to add up to 90 degrees. So in order to figure out what x could possibly be, thus telling us what two angles could help us make this equation true, we have to first figure out what x is. So that's why I set up this equation right here. This would be a good time to write this down into your notebook as well. We know that 2x minus 4, which is coming from our sine function above, and 3x plus 9 is equal to 90 degrees. And we know that because in a right triangle of the three angles, one of them is already 90 degrees. The two remaining ones have to add up to 90. By combining like terms, we would combine this to 5x plus 5 equals 90. Simplifying, we'd have 5x equals 85, and then figuring out that x is equal to 17. With that information right there, that's not the degree measured. That's just what x would equal in order to then figure out what angles would make this equation true. With each angle, we're going to take that 17 and we're going to substitute it into the degree measures that we've got. So 2x minus 4 is equal to 2 times 17 minus 4, which gives us 30. So one of our angles that makes this true, it makes this equation true, is 30 degrees. And our other angle of cosine 3x plus 9, whatever 3x plus 9 is, when we substitute a 17 in there, we get 60 degrees. So to make this equation true, we know that the two angles that would make that true, that would satisfy that, would be 30 degrees and 60 degrees. Let's try this one on your own. Find two angles that satisfy the equation. So you can pause the video and try it, or you can follow along with me. Finding two angles that satisfy the equation, just to remind us, we know a few different things. We know that the sine of an angle and the cosine of its complement are equal to one another. We proved that earlier in our notes. That's why we can say that these two items are equal. We also know that this quantity of 3x plus 2 degrees, whatever that is, and the quantity x plus 44, when we add those together, we know it's going to make 90 degrees. And again, we know this because in a right triangle, the 90 degrees has to be split between these two angles in some way. So by adding both those up to make 90, we'll be able to figure out what x is. So by combining like terms, we're going to have 4x plus 46 equals 90. If you do 90 minus 46, you get 4x equals 44, and then x equals 11. Remember, that's not one of the degree measures. That's just what x is equal to then find them. So let's find the two angles. 3x plus 2, we would have 3 times 11 plus 2. That'd be 33 plus 2, which is 35. So 35 degrees is one of the angles that makes that true. We also have x plus 44. 11 plus 44, we would have 55 degrees. Now let's think about this. Is 35 plus 55 equal to 90? Yes, it is. So I know I found the two angles correctly to make this equation true. Moving forward, you'll work on your work session, which is going to be part of your homework that's due on Thursday, along with 15 questions of the study guide. Work hard and email me if you have questions. I'll answer any loose ends or tie up any loose ends tomorrow when we get back to class.